have for me anything.
So I have one more problem.
Yes. Yes.
Let's finish the chapter. That's when we get the precise limit.
Okay.
Number 3, it said use the graph of f of x.
So we are into that 4 then? Or page number or something? Can you give me anything?
Page number 116. 116, yeah, 116.
Okay, so which problem is that?
Number 3.
Okay, on 117. Okay,
116.
use the graph of f of x.
3 is on 117.
That's okay. Find the number delta. So we had something similar. If we need to do this, I will do it. So if x minus 4, so if we pick x close to 4, not more than delta, then this will imply the square root of x minus 2, which is the function minus the limit, is less than 0.4. So it says use the graph to find the number delta. So when I look at the graph, let me see if I find my pencil so I don't write on the book, on the page here. Okay, so we are really asked to find this distance, and we're asked to find this distance, and which of the two we will choose as delta. So I find this and I find this. Which of the two will I use as delta? Let's say I have this number is A and I have this number B. Which of the A or B will I use as delta?
Shorter one.
Exactly, the smallest of the two. We know that because this will be a one interval where for sure all x values will give of f of x within epsilon away from 2. But if I choose the bigger one, which will be this, I could choose x or pick x right here, and therefore f of x will fall outside of the epsilon interval. So yes, once I determine A and I determine B, I will definitely have to assess which one is smaller, and that will be definitely my delta. Is that clear? Do you remember discussing that? Do we remember discussing that? Okay, perfect. So I know that it's clear now that, which we have here, that epsilon is how much? 0.4. This is our epsilon. So we want to solve this inequality. We will determine these two values. We will, from this value, I'll subtract 4 to find this distance that I called B a second ago. Then I will determine this point, and I will subtract from 4, subtract this number to find this distance, and then I will choose the smallest of the two to be our delta. This is what we did. Is that okay? Okay, so I have this inequality to solve. How do I solve this inequality? Yes, how do we do it? No. 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 Nope. So how do we solve the absolute value inequalities? Anyone remembers how to solve the absolute value inequality? So I'm asked to find these numbers whose absolute value or distance from 0 is less than 0.4. Where will I find these numbers whose absolute value, which is the absolute value or distance from 0, is less than 0.4? Where will I find them? Say it again. Oh, you're so far out. Say it again.
Isn't it between negative 0.4 and positive 0.4?
Exactly. Without translating this inequality into this inequality, I will not be able to solve. So that's my first step. So the absolute value, this number in absolute value less than 0.4 must be between negative 0.4 and 0.4. So then the distance between whatever I have here and 0 is less than 0.4. So the expression has to be between negative 0.4 and positive 0.4. Is that clear? Do we remember that? Okay, how do I continue solving this? Only now I can add 2 to all three sides. So then I have here 1.6, I have here the square root of x, and I have here 2.4. Good. Now, since and only because this is a positive number, this is a positive number, and this is a positive number, I'm allowed to do something special that normally I would not be allowed to do in an inequality. What? Exactly. So I square this, and I square this. Only because they are all positive. So is 1 less than 2 less than 3? Yes. Well, 1 squared will be less than 4, will be less than 9, because they are all positive. So squaring them keeps the inequality intact. Good. So then I go back to my graph. So I have, we had 4, right? We had 4. So then what is this distance and what is that distance, right? I solved the inequality, right? So now, in order to determine delta, I will have to subtract, because this is the same idea, negative delta less than x minus 4 less than delta. I will have to subtract 4 from all three sides. So now I'm ready. So subtract 4 from all three sides. 1.6 squared less than x minus 4 less than 2.4 squared minus 4. So let's calculate all these. What do we get? 1.6 squared is what? 2.56 and minus 4. Minus 4 from all three sides. And minus 4, negative 1.44, and this one, 2.4 squared minus 4 is 1.76. Good. So, say it again. I couldn't hear you. No. So remember, from this, in the epsilon delta definition, I have to construct that in order to identify delta. So I have to have x minus 4. Okay? So the absolute value of x minus 4 must be less than 1.76. Or the other option is x minus 4 less than 1.44. Because remember, I have two options. What will this change into? This will change into negative 1.76 less than x minus 4 less than 1.76. What will this change into? Negative 1.44 less than x minus 4 less than 1.44. Now I have to make a decision. So let me write this for everyone to see, and then you'll make a decision. And you'll tell me what to write. So with this, I obtain this interval, which changes into negative 1.76 less than x minus 4 less than 1.76. But this will be further to the left of negative 1.44. Will be much lower than that. Much, I shouldn't say much, but to the left. Now this interval will change into x minus 4 less than 1.44 less than 1.44 with minus. So this will be the second interval, and this will be the first. This is the second, and this is the first. So I have to choose in such a way that I can have this interval included here. This interval is not included here. This interval is included here. But this one is not. This one goes outside here. So then which is our delta?
Should be
1.44.
essentially you take this second equation and you put the negative 0.4.
The second equation, you mean the inequality?
Yeah, essentially the second inequality, and you do
The absolute value x minus 4 less than or less than 1.44. What will be the other option to think about? So you have the function is the square root of x, and you have f of x equals 2.4 for a particular value that we don't have for this one, right? I just want to bring the book over, right? So when I plug in the square root of x, when I plug in this number that I don't have, I will get 2.4. When I plug this number in, that in the square root of x, I will get 1.6. So what do we get? So the square root of x equals 2.4, and the square root of x equals 1.6. And we're asked to find x. What do we get? Maybe I shouldn't have written x because it's a value that I don't know. I'm going to call it a, and I'm going to call this b. So then my a will be 2.4 squared, and my b will be 1.6 squared, right? So when I square that, that's the other way, and you don't have to solve the absolute value inequality. So 2.4 squared will be 5.76, and 1.6 squared, you already gave that to me. I already have it. It's 2.56. So a will be 5.76, and b will be 2.56. So again, you choose the method you like. I wanted to review solving absolute value inequalities with you. So this is my 4, and this is my 5.76, and this is my 2.56. And I determine this, and I determine this, and the smallest of the two has to be what I'm looking for. And of course, what we just did a second ago, this is 1.44, and this is 1.76, as we knew. So then, therefore, delta must be 1.44 because it has to be the smallest of the two. Exactly the same. You either solve the inequality, the absolute value inequality, or you use the function.
so if we agree to you can always use the function.
Say it again.
You can always use the function.
But what do you think? How do we get this number?
You know what I'm saying is like we have two ways to solve it.
Yeah, in this case, I decided to use the solving the absolute value inequality, but you can use the function as well, depending on what's given in the problem. But yes, so f of this number must be 2.4. F of this number must be 1.6.
So then we would.
And we got the same thing.
So we spread it 2.5. Oh no, never mind. I got one. Okay.
Is that okay?
Yeah.
Good. Anything else? Other questions? So, yes.
We look at 25.
Yes.
On page 163.
25 on page 163. Let's take a look. 163. 162, 163, number 25. 25. Yes. So we have f of x equals x squared minus 2x cubed. We're asked to find the derivative of the function using the definition of the derivative. For the definition of the derivative, not the derivative at the point, we have how many possibilities? So we're asked to find f prime of x. If I'm asked to find f prime of a, which is not even the case, I'm not given a, but if I'm asked to find f prime of a, I have two options. If I'm asked to find f prime of x, is just one option, which is the limit of the difference quotient and nothing else. So f prime of x equals the limit as h approaches 0 from f of x plus h minus f of x divided by h. Nothing else. If I'm asked f prime of a, however, I have two options. The first one with the same thing with a inside and h approaches 0. And the second option is f of x minus f of a over x minus a. Okay? But I only have one option for f prime of x. Good. So I'm given the function. The function is x squared minus 2x cubed. Can anyone get us started? What do we have to write after this?
Equals h squared.
Yes. So well, let's write it like that first. So x plus h squared minus 2x plus h cubed minus x squared plus 2x cubed divided by h. Tell me in a blink if this is okay or not. Yes? Perfect. Before I even look, let's analyze this. Don't even look. What has to happen? H in the denominator has to eventually go away. And definitely when I expand the top, what terms must go away for sure?
Anything from h.
Everything that does not have h in it. Yes, correct. So now, when I'm asked to find the limit, what is the first step I have to perform? Plug it in. I know it's 0 over 0, right? It has to be, right? It's a difference quotient, right? So let's check. So this will be x squared, and this is negative x squared. This will be negative 2x cubed, and this is positive 2x cubed when h is 0. And this is 0, right? The top is 0, the bottom is 0, so of course there is hope, right? This is a polynomial function. Are polynomial functions differentiable? Yes. Yes. They are smooth, continuous functions. They will be differentiable everywhere. We know this a theorem from last week, right? Polynomial functions, continuous and differentiable everywhere. So I know this function has a derivative at any point. Good. So now I know how to square this, but this needs a little bit more work. I personally remember how to cube it, but you may not. So let's take it on the side. So x plus h cubed, I know is x plus h squared times x plus h. So far, so good? Now, we have a contract, right, that we made on x plus h squared. I cannot even believe that 5 weeks ago. It's already 5 weeks. So what is this?
X squared plus 2h
Excellent.
plus
Perfect. Excellent. Thank you. So now I will continue distributing. Since I start here with 2 terms, you can do whatever you want, but I will distribute this to these 3 and then h to these 3. So x cubed plus 2x squared h plus x h squared plus x squared h plus 2x h squared and plus h cubed. So now this is this piece. And I will put it in the difference quotient in the limit, of course. Remember, the limit operator cannot go away till the very last step. So you have to carry the limit operator with you everywhere you go till the last step. So I will continue here. Limit as h approaches 0. Is this okay? I can combine like terms, of course. This will give us 3. And this will give us 3. These two. these two 3 and these two 3. So 3x h squared plus h cubed. It's Pascal's triangle that we use normally when we expand to the power 3, 4, 5. Okay, so I have this piece. I will expand x plus h squared. You already gave it to me. X squared plus 2xh plus h squared. I will distribute negative 2 to these 4 terms. So minus 2x cubed minus 6x squared h minus 6xh squared and minus 2h cubed. And I have to copy these 2 terms. So minus x squared and plus 2x cubed, everything over h. Any questions so far? So it was just multiplying, right? Distributing, squaring. Everyone okay with this so far? Perfect. So now I see x squared, and I'm looking for it to go away, and it does. I see negative 2x cubed, and I'm looking for it to go away, and it does. I have nothing else. I don't see anything else. I have 2xh. I don't have anything else with 2xh. I have h squared. I don't have anything. These two are not like, that's fine. That's all I can do. So limit as h approaches 0. Obviously, the remaining terms, 1, 2, 3, 4, 5 terms, must have what in common? Must. Mandatory. So 2x plus h minus 6x squared and minus 6xh and minus 2h squared. So 2x h minus 6x squared minus 6xh and minus 2x minus 2h squared. Good. Now what do I do next? Say it again. Very good. Write 1 because if you don't, you may consider it's 0 or something. Good. Now I can drop the limit operator. But after I notice that this will go to, this will go to, and this will go to, so the simplified form, 6, very good. So 2x minus 6x squared. And what does this represent? Can anyone tell us what it represents?
A function
That gives, it's a function, clearly, a function that gives
that gives the
rate.
slope
Okay, very good. The slope or the rate of change. Excellent. Of the function f at any point, any point or a given point on the graph of the function, or any point that is a part of the function, a point of a function f of x, not a function f of x. The rate of change at any point, or the slope of the tangent line at any point on the graph of f. It is definitely every point because we know the function is continuous and differentiable. It's not differentiable because it's continuous. It's differentiable because it's a polynomial function. Because we know not all continuous functions, what? Not all continuous functions are correct. In how many ways a function is not differentiable? Which ones? When it's not continuous. When it's not continuous. Cusp or corner. Excellent. Good. Next question, please. Anything else? 48 on 152. One 52. 152. 48. Very good. The number of bacteria after T hours, I'm assuming is this one, right? The number of bacteria is this?
Yeah.
Okay. After T hours in a controlled lab experiment is N equals f of t. The number of bacteria after t hours is a function. The number is a function of t. I have to take notes. So n equals f of t. Perfect. Part A. What is the meaning of the derivative f prime of 5? What are its units? Can anyone give us an idea?
This is the bacterial growth per hour at 5 hours.
Exactly. So the rate, so the first one, the rate of change of n, which is number of bacteria, per hour at t equals 5 hours. Very good. And the measurement unit, because it's a rate of change, the measurement unit has to have a ratio. It's a ratio, something over something. Bacteria or number per hour. Very good. Any questions? Is this okay? Part B. What does the statement f prime of 800 equals 17 mean? So part B.
Well, that's the previous question.
Oh, yes, of course. Suppose there is an I know, I do that a lot. Ben knows me, so that's why he's keeping an eye. Suppose there is an unlimited amount of space, so this is not part of that problem, it's a problem. Suppose that there is an unlimited amount of space and nutrients for the bacteria. Which do you think is larger? F prime of 5 or F prime of 10? If the supply of nutrients is limited. So we have unlimited. So right now, first part is we are in the unlimited amount of space. So they can grow freely. I would agree. So this is bigger than f prime of 5. So here's the idea. Bacteria normally grow exponentially. We know that. It's a fact. It grows exponentially. So if there is no limit, at 5 and let's say at 10, remember this is the slope of the tangent line. So let's say it's about ratio 1/2. I'm just making this up. But right here at 10, look at this. This appears to be like 2/1. So if the resources and the space for bacteria to grow, if those are unlimited, then this definitely is a smaller rate than here, because they grow very fast and they multiply very fast. So they will continue much faster here because there are many more than here. Now, what happens, for example, if there is a limit? Well, normally could be something like this. If it's a cap, right? So then what will you say about this? The rate of growth here and the rate of growth here between 5 and 10. If there is a limit, if there is a cap, they don't have unlimited resources, they don't have unlimited food and unlimited space to grow. So that's the second part. If the supply of nutrients is limited, would that affect your conclusion? And the answer is yes. Because if there is a cap and they cannot go beyond this line, then look at what happens at 5. Much steeper increase, right? Much steeper slope versus here. So these will be reversed in the cap and limited situation. Very good question. Anything else? Is there anything else that you have for me right away? I would like to go over this, whatever you think is needed, and then I would like to make a list again of what you expect to see on the test. And of course, a lot of it is here. Okay. So I created this document. In Calculus 1, we really look at all these. And the list continues, but I had to stop with limits of integrals, which is improper integrals, actually, which is Calc 2. So our Calculus 1 ends here with number 18. Beyond this is going to be Calculus 2. So now, do you think we need to, for example, look at this? I mean, we know how to handle something like this. I don't think we have difficulties, but please say yes or no. No. Okay, I think we handled a couple of these, and this is an example we did together in class. Yes, I took it from your book. So we handled this. We worked on it. Is this okay? Okay. Now, infinite limits. So the answer here could be infinity. Okay? Or a vertical asymptote. So this is just a factor, factoring a limit, the top and bottom in a limit. Here is just looking at absolute values, several, I would say at least two options, right? Because the absolute value has two options, the function will have two options. Here, when the answer is infinity, when x approaches 2 from one side, or 2 from the other, or 2 from both sides, either side, and the answer is infinity, of course we know that x equals 2 will be a vertical asymptote. So if the function has a limit like this, or like this, or like this, on near x approaches 2 from either side or from 1 or 2, then I have x equals 2, it's a vertical asymptote. Do we remember this, or we need to practice this one? Okay, so 1 minute. So let's work on it. Write it down, and let's work on it. Good idea. 1 minute. And tell me what you get. Number 3. We're working on number 3. Do we have an answer or not yet? Yes? So this is the limit as x approaches 2 from the left, from x squared minus 2x divided by x squared minus 4x plus 4. I plug in 2, I get 0 over 0. There is hope, no guarantee whatsoever, but there is hope. And I know for sure that something has to happen. The top and the bottom must have what?
Common factor.
Which is?
X minus 2.
Very good. It has to happen. Good. So how do I get that from the top? Yes, multiply by x. And what about the bottom? X minus 2 indeed. One factor will go away. I should have put a square, but it's the same thing. And now, 2 from the left. Now I have a positive number over 0. And 2 from the left is 1.9. 1.9 minus 2. The top is positive. The bottom is negative from the left. And the answer is negative infinity. What do we conclude about x equals 2? As x approaches 2 from the left, the function values approach negative infinity. Therefore, x equals 2 is a vertical asymptote. Very good. Perfect. Okay.
So essentially, you're just back.
Depending on the function. Depending on the function. Okay. What do we know about this? Which we could not prove. We will very soon. But just with the graph. We looked at the graph. So what is this answer? 1. We can never forget this. Also, you can write limit as x approaches 0 from either side from x over sine x is still 1. Now, we looked at this limit before. We did not look at this limit before. So this limit is 0. We will talk again about it. I would not put it right now on the test because I want to prove it to you. This will be on the test because this is very important. But with this one, I will have to wait. I want to wait till I can prove this to you, so you don't have to memorize it. Okay. Now, this cotangent 3x over cotangent x, we can try and get this limit. This one we did together in class. If you want, we can do it again. But I like to work on this problem. So this is limit as x approaches 0 from cotangent 3x divided by cotangent x. Even if you are tempted, I will erase this because this is horrible. What I'm going to do is absolutely unacceptable and horrible. You can never simplify it like this, because the function at the top is a function of 3 times an angle, and the bottom function it happens to be the same function, but it's a function of an angle. So you cannot simplify this with this. So what I just did, as I said, I'm just making a point. Do not ever try to do something like that. Okay, so then limit as x approaches 0, cotangent 3x over cotangent x. With parentheses or without parentheses, they are the same. I just don't want you to be tempted to try to simplify this with this. Okay, so now what do I know about cotangent? Is cosine 3x over sine 3x over cosine x over sine x. Do we agree with this? So it's cosine over sine. Do we agree? Yes? Now, notice that I didn't plug it in. And I always say, don't even try to do anything before you plug it in. I just wanted to show you that cotangent at 0 is undefined. In other words, it would be infinity. And this will be infinity. So it's better to try to simplify the function in this case and then plug in 0. Because we don't know how to handle this yet. We will after chapter 3, or halfway through chapter 3, we'll know how to handle this. So keep just bear with me right now. So I just changed this into cotangent, cosine over sine, and cotangent, cosine over sine. Are you okay with this? How do I divide two fractions? Right. No, there is no common denominator when I divide. So it will be cosine 3x multiplied by sine x over cosine x multiplied by sine 3x. So I copy the fraction at the top and I multiply it by the multiplicative inverse of the other. Okay, now it's better to plug in 0 and see what happens. So where does cosine 3x go when x approaches 0? Cosine is measured on the x-axis. 1, very good. Where does cosine go when x approaches 0 from either side? 1. Where does this go? 0. This goes to 0, and of course this goes to 0. So the limit is 0 over 0. So there is hope. No guarantee. Like here, there was hope. I was able to cancel a factor that was a problem, but I was still left with one of them, the other one in the denominator, so I had no choice. Although I had hope, it turned out not to exist. It's negative infinity, which means does not exist, but I have to write negative infinity. I cannot write DNE. Okay, good. So then in this case, I know it's 0 over 0. Let's see what we do. Let's leave these terms as they are, these factors as they are, because they approach 1 and they are not in the way of anything. So I'm going to keep them as you see them here. So cosine 3, you cannot simplify anything, just keep them as they are. Now, sine x. Would you allow me to write this? Yes, I'm going to write 1. So I broke this fraction into a product of two fractions. Is this okay? Are you okay with that? Is sine times 1 sine and 1 times sine 3x sine 3x? But now I am going to do something and you'll say, why? And I'll explain why. I'm going to multiply the denominator by x and the numerator by x. I'm going to multiply the numerator by, what do you think? X. Yes. And 3x. I didn't do anything. Multiplying by x and dividing by x is multiplying by 1. So I didn't change anything. These can go away. Multiplying by 3x and dividing by 3x, I did nothing. These two can go away. However, I am trying to use my result. I'm trying to use what I know. So I know that, and I would like you to write this with me, please. This limit, with 1, of course, is not only when x approaches 0. In general, limit as long as these three quantities are identical. And of course, this number is 0. Because if this number is 3 or 5 or whatever else you want, the answer is not going to be 1. So as long as this piece, and this piece are all the same, and of course I have sine, the answer will always be 1. Let's see if I have that in my problem. So as x approaches 0, where will this go? Good. As x approaches 0, is like saying 3x approaches 0 if you multiply both sides by 3. So if I tell you x approaches 0, indirectly I'm telling you 3 times x approaches 0 as well. Where does this go? 1. Because remember, even the reversed situation, x over sine x when x approaches 0 is 1. So this piece, and this piece, if they are all the same, 3x, 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 the answer will be 1. So then, we know already that this approaches 1. And now please tell me what is left. 1, 1, 1. What is left? So when I simplify x with x, what do I get? What is the answer? Exactly. 1 from the top, 3 from the bottom. I would like to work on another problem like this before we move on through the rest of the list. Okay, so let's look on page 'Yes, I'm going to look at limit Sx approaches 0 from sine 3x multiplied by sine 5x divided by x squared. I will plug it in first. I have to see what's happening here. So what do you think about the top? Yes, this approaches 0, this approaches 0, the bottom approaches 0, 0 over 0. However, this is not the type of limit in which I factor. So I can say there is a factor of the top that will go away and a factor from the bottom that will go away of x. I can't do that. But I do know that when x approaches 0, 3 times x also approaches 0, as well as 5 times x approaches 0. Therefore, how will you split this limit? And by the way, I just want to quote here a limit law. The limit of function f times function g times function h is the limit of this, if it exists, times the limit of this, if it exists, times the limit of this, if it exists. So that's what we used, one of the limit laws. The limit of a product is the product of the limits, if all pieces exist. Okay, so give me an idea of how you would split this. For now, just as a first step. Sine 3x over, yes, sine 5x over x. But the pieces are not the same. Remember, I need this piece, and the piece in the denominator to be the same. Then I need this piece, and the piece in the denominator has to be the same. So what am I missing here? I'm missing a 3, so then I multiply the top and the bottom by 3, which means nothing. I didn't change anything. Multiplying the top and the bottom by 3 is multiplying by 1. What am I missing here? The 5. So multiplying the bottom by 5 and the top by 5 will not make any difference because this is 1. However, now I can split it because the limit of this as x approaches 0 is, or if you want to write as 3x approaches 0 is 1. So the limit of this as x approaches 0, or if you want 5x approaches 0 is the same thing, will be 1. So what will be the final limit then? 15. Any questions?
Previous one.
Yes.
What was
go to 1, like for the x and the
X simplified with x. X divided by x is 1. X divided by x is 1.
Okay, that makes sense.
Because I have an x from the top and an x from the bottom. They go away. Otherwise, I will have a problem. I will have the same problem again, 0 over 0. But they go away.
Okay.
Very good question. Thank you. Any questions on this? Let's look at one more. Limit as t approaches 0, tangent 60 divided by sine 2t. I have to plug in 0 first. What do I get at the top? Let's say we don't know because it's tangent, but I know that this is sine 6t over cosine 6t divided by sine 2t, correct? Sine 2t over 1. Let's change it into a fraction. Limit t approaches 0 from sine 6t times 1 over sine 2t over cosine 6t. And now it's easier to identify. Where does the top go? 0. Where does the bottom go? Yes, because this approaches 0, sine 2t approaches 0 when t approaches 0, and cosine 6t approaches 1. Very good. So it's 0 over 0 indeed. Leave the cosine alone because it's not creating any difficulties. So I'm going to leave it as 1 over cosine 6t. But I'm going to break this into sine 6t over 1 times 1 over sine 2t. It's the same thing. 1 times this times 1 is this. Cosine times 1 times sine is this. But now you'll tell me what we need. When t approaches 0, it's like 6t approaches 0, and it's like 2t approaches 0 because you multiply t approaches 0, multiply both sides by 2 or by 6. So then what am I missing, really? But I cannot just put the 6 in the denominator. Careful. I'm not saying you said that. I'm just pointing it out. So you can multiply the denominator by 6, but you have to multiply the numerator by 6. What about sine 2t? 2 and 2. I choose to multiply the top. I have to multiply the bottom. And now please tell me what happens next. Where does this go? Oh, of course. Not just 6, but 6t. Of course. You may have not paid attention, but I meant to write that. So, of course. So 6t and 6t. Just 6 is not going to work. And 2t and 2t. Good. So now sine 6t over 6t. Where does this go when 6t approaches 0? Perfect. Where does 2t over sine 2t go when 2t approaches 0? 1. So now I have this which approaches 1. I have 6t and I have 2t. So a t from the top will go away with a t from the bottom. And the final simplified form is 6 divided by 2. So what is behind all this? Well, bottom line is algebra. We will have more examples of this in chapter 3 as well. I just want you to, for now, for this test, I only want you to remember this. Okay? We're not going to go for this test into sophisticated stuff. Oh, yeah. Sorry? I just gave it out today. It probably came in right after I did that. I'm sorry. I apologize. Okay, so for this test, that's all I want. I want you to remember this. Okay, radical functions. The question here will also ask you to find the domain of this function, not just find the limit. We did a problem or a couple of problems like this. If you want to redo it, please let me know now. Okay, so then we have the limit. So we have limit of the square root of 16 minus x squared as x approaches 4 from the left. So the question will ask you to find the domain of this function first, and then find the limit. So what do I have to write in order to find the domain of this function?